Hey, this is Mr. Ward, and I'm going to do a few hints and pointers for Chapter 4.1, Problems 5, 6, and 9. And I'll take a look at Set C and Set D and see if I can give you some hints there as well. So let's take a look. So as you know, Chapter 4, Section 1 is all about detour problems. So that's what you can expect. And so number 5 does not disappoint. You are asked to prove that angle MKP and SQP MQP and SQP are congruent. And to do that, it would be really useful to be able to prove that triangles MQP and SQP are congruent. If you could prove that, then you could prove those angles. But you don't have enough information. We have MN is congruent to NS, I would say SN. You have MP and SP are congruent to each other. And those are your givens. We can, of course, assume from diagram that PN is congruent to itself by the reflexive property, which will then allow us to prove that triangles PMN and PSN are congruent. And that is what you need in order to prove that these two triangles are congruent, because you can say PQ is congruent to itself by reflexive. You know that MP and SP are congruent, and by Kappa-Kadaka, you've got angle MPQ and angle SPQ are congruent. And that gives you everything you need for that one. If you take a look at number 6, we are told that ABC is isosceles, and the base is BC, and we're told that AD is perpendicular to BC. Okay, and so that tells us that this right here, that these angles BDE and CDE are right angles, and that's helpful. What we're trying to figure out is BEC. BEC, is that isosceles? That's what we have to prove. Now, what would be useful to do that would be either to prove the base angles are congruent or the two sides are congruent. But we don't have enough information. We could prove that this side is congruent to itself, ED, and we can prove that since BC and AD are perpendicular, we could prove that there are right angles on either side here, EDC and EDB. Those would be congruent angles, but we don't have enough. We just have a side and congruent angles. So let's look at another couple of triangles that would allow us to prove that BE and CE are congruent. If we could prove that ABE and ACE are congruent, we could prove that these two triangles are congruent, and therefore BE and CE are congruent. Do we have enough information for that? Well, we know that this side is congruent to this side. We know that AE is congruent to itself, but we still don't have enough information there. So let's back up and let's consider triangle ABD and triangle ACD. Well, we know they're right triangles because of this perpendicular angle situation here. And we know AB and AC are congruent, and those would be hypotenuses of those right triangles. And we know AD is congruent to itself by the reflexive property. And now, since they're right triangles, the hypotenuse leg theorem postulate comes into play. And since we can prove this side, this leg, and this hypotenuse are congruent to this leg and this hypotenuse, we can prove that ABD and ACD are congruent by hypotenuse leg. Now, once we have that, now we can prove that triangles BDE and CDE are congruent, and that'll lead us to the isosceles triangle by Kappa-Kadaka. So we now, by Kappa-Kadaka, we know that BD is congruent to CD because these larger right triangles are congruent. And so now we have a side and a side. We have a side congruent to itself, and we have angles that are the included angle is congruent as well. So side angle side angle side will give us these two smaller triangles congruent. And once we have that, you have everything you need in order to prove both that EC and EB are congruent and that angle ECD and EBD are congruent. And that will lead you to proving this is isosceles. Look at number 9. Number 9 looks like a paper airplane, and it screams for an auxiliary line to be drawn right here. And in fact, you're going to need that auxiliary line. I'm going to draw on this one. I'm going to start by drawing an auxiliary line, which is, of course, congruent to itself. And that's just something that will be useful later. We're trying to prove that angle 1 and angle 2 are congruent. To do that, it would help to be able to prove that PRS and PUT, those triangles, are congruent. We know that PR here is congruent to PU. We also know that QR here, QR and QU are congruent. And we know that RS here and UT are congruent. Now that's a side and that's a side for this little triangle. That's a side and that's a side for this little triangle. But it's not enough to prove these two triangles are congruent. So what we probably ought to do is look at PQR and PQU. We do have enough information to prove those are congruent by side, 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 side. And if we can prove that those triangles are congruent, then we can prove that angle R is congruent to angle U. And now you have enough with a side angle side to prove that PRS and PUT are congruent. I hope that gives you enough to figure out that angle 1 and angle 2 are congruent. I believe it does. Let's take a glance at the problems from set C and set D. So with number 13, we are asked to prove that AE bisects BC. Now, to prove that, it would be useful to prove that ABE and ACE are congruent, or that DBE and DCE are congruent. All right. We know that AB is congruent to AC, which tells us this overall triangle is isosceles by definition of an isosceles triangle. We know BD bisects ABE and CD bisects ACE. Okay, so that tells us that these base angles have been bisected. Well, these base angles are congruent because it's isosceles according to theorem 19. The angles that are opposite congruent sides of a triangle are going to be congruent. And since these are congruent, half of them are congruent. And that will prove to us that BDC is isosceles because it also has base angles that are congruent. And if that's true, then this side and this side are congruent. This angle and this angle is congruent. And let's see, what can we prove from there? We can prove this angle and this angle are congruent. We know that this side and this side is congruent. Let's see here. So here's where the detour part comes in. To prove that these two bottom triangles are congruent, we now need to prove that these two sort of paper airplane wing triangles are congruent. And we can do that because we now know we already know AB and AC are congruent. We can prove that BD and CD are congruent because this is an isosceles triangle and AD is just congruent to itself. So side, side, side gets us that. Then we can use these congruent triangles to prove that angle EDB and EDC are congruent because those angles are supplementary to these congruent angles and therefore also congruent. So we will be able to prove that these angles are congruent. We know this side is congruent and we know DE is congruent to itself. And so now we got side, angle, side, and that will give us everything we need to prove that BE and CE are congruent, and that will give us that AE bisects BC by definition of a bisector. Now let's take a look at 14. 14, we're trying to prove that PQ bisects RPS, this angle here. Okay, so we've been told that PT and PU are congruent. we've told that PS and PS and RP are congruent. So we know this is congruent and this is congruent. We know that this is congruent and this is congruent. So let's label that stuff. So we know that PT and PU are congruent. And we know that PR and PS are congruent. All right. So we have some overlapping triangles. That's something we've got. Now, we don't have enough information to prove that angle PRQ and SRQ are congruent, though, with this information. So it would be helpful if we could prove that TQP and UQP are congruent, or that RQP and SQP are congruent. If we could prove either of those, then we'd have what we need, because then by Kappa-Kadaka, these angles are congruent. But we can prove that triangle PTS and PUR are congruent, because there's an angle that's congruent to itself. This angle is congruent to itself. So we have side and a side and the included angle, side and a side and the included angle. So we can prove that PTS and PUR are congruent. And that will allow us to prove this. That allows us to prove that this is congruent to this. It also allows us to prove that this angle here is congruent to this angle. It also allows us to prove that this angle here is congruent to this angle. And now you actually have enough to prove that these little triangles are congruent to each other, because you got an angle, side. Well, actually, no, we don't yet. Now, do we have enough to prove that this triangle is congruent? Let's consider that. Yes, I think we do. Let's see. We've got, what we do have is we can prove that PTQ and PUQ are congruent. Okay, and let's see. So we can prove that, of course, PQ is congruent to itself. We'll pick purple for that. We can prove that is congruent to itself. Okay, we have a side. Okay, we have this angle. We don't yet have these two angles. We have this angle, this side, and side angle does not prove congruence. I think this may call for an auxiliary line. So I'm going to draw this, and I probably should use a different color for that. I'm going to use a sort of off green. I'll put that on top of that. We can draw an auxiliary line, and then we can bring this down to here. Okay. Now, when we bring this down to here, because this and this are the same, then we can extend some congruent angles. Now, we could actually say that this and this are congruent, because this is an isosceles triangle. Now, once we've proven this, that this and this are congruent, and this is an isosceles triangle. All right, I'm going to back up here for a second. I'm going to undo what I've done here, but I think I'm on the right track. Sometimes you got to puzzle around with these a little bit. So, something I definitely notice is it would be useful to draw a couple of auxiliary lines on this one. So, I'm going to extend PQ like that. Okay. Now, if we know that this side and this side are congruent, then we know this whole thing is isosceles. Okay, so we know those are congruent with each other. And I know I picked colors that are kind of close, so I'm going to do that mark. Now, We also know some other things. I'll label some other stuff we know. We know that this side here and this side are congruent. And then we're able to prove, because this angle is congruent to itself, that this triangle and this triangle are congruent. Okay. Let's go over here. Okay, so then we know that this angle and this angle are congruent by kappa kata ka. We'll be able to prove that. You'll be able to prove that this side and this side are congruent by kappa kata ka. We're still trying to figure out how we can prove that these two angles here are congruent. Okay, if we could prove that this triangle here and this triangle are congruent, then we'd be good. And the key thing I think for that is proving that PQU as a triangle would be isosceles. Well, let's see what we've got. Well, we know that this side and this side are congruent, and then we can actually say that these angles are congruent, which means that these angles are congruent, which means that TQ and UQ are congruent. Since we know we can find that, then we can prove that PUQ and PTQ are congruent. So we have proven, we can prove that TQU is an isosceles triangle. And once we've proven that TQU is isosceles, we can prove TQ and UQ are congruent. And that's the missing side we need to make PUQ and PTQ congruent, because this, we know we can prove that PQ is congruent easily because that's reflexive. We were given PU and PT. Now we have TQ and UQ, side, 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 leads those triangles, and then these angles are easy to prove. So 15 may require a couple of detours. So we're trying to prove AFB is isosceles, and we've been given a bit of information. We know that AD and DB are congruent. We know that AE and BC are congruent. And we know that CD and ED are congruent. So right off the bat, we have enough information to prove these two triangles are congruent, and that's going to give us some angles that'll be useful. So all the angles of these two triangles are congruent. Now, let's see what that gives us for a next layer of congruence. So can we prove, let's see, what other triangles contain some of the angles that we have, or contain the sides that we have? Okay. So there's this triangle and this triangle. If we could prove that AEF were congruent with AEF were congruent with BCF, then that would allow us to prove that this is congruent. And it feels like that might be one avenue, because let's see, to do that, we're going to need possibly to prove, let's see, if we maybe prove this larger triangle is congruent to this larger triangle, that might work. But let me explore this for a second. One thing we can definitely state, if AD and BD are congruent, is that angle DAB and angle DBA are congruent, because this would make an isosceles triangle with a base AB. And that helps a bit, because that kind of starts to pin things down here. Now, if we could then prove that this angle DAC and this angle DBE were congruent, then we could use subtraction to prove that this angle CAD and this angle EBA are congruent. Now, another thing I feel that could be useful to us is to just note that AB is congruent to itself. So now we have kind of a piece of a couple of other triangles that we might be able to work with. Now, of course, back a while ago, we proved that AED and BCD were congruent, which is going to point to a couple of other angles being congruent. So let's label them. We know now that this angle and this angle are congruent, which by addition, we could add this angle here, and then we can declare, well, let me see if I can pick a color I haven't picked already. Dark blue, I guess. We can now prove that this angle is congruent to this angle by addition. And now you've got a side angle side and a side angle side angle side for EBD. So I'll pick another color for that. Use a yellow since we haven't used a yellow for a side. That this triangle here, so EBD and CAD are going to be congruent. And that, I think, will clinch it, because that'll prove that this angle here and this little angle are congruent. And by subtraction, these angles here, CAB and EBA, will be congruent, and that'll clinch that AFB is isosceles. Now, the last bit, you can bet problem set D is going to be super complicated, but let's take a quick look at this. So triangle LTM is isosceles with LT and TM being congruent. Okay, cool. We've proven that. We know that TQ is a median. Now, we want to prove that PS and SR are congruent. Okay. So to do that, it would help to be able to prove that PST and RST are congruent, or that KPS and KRS are congruent. If we could do that, then we could prove that these two sides are congruent. Now, we know that this here makes an isosceles triangle. And we know that this is a median. Now, we've seen in other isosceles triangles that a median of an isosceles triangle we could also prove is an altitude. So you could go through the process of proving that this is a median, which means this is congruent to this. It also is an altitude, so that will prove, and you'll have to prove that it's an altitude using some of the proofs from earlier. That means that's at a right angle. And so now you have enough information to prove that this triangle and this triangle are congruent. Okay. And if we can prove that, then we'll have, so we know that this angle is congruent to this angle. We know that this over angle is congruent to this angle. And so this angle would be congruent to this angle. Now from there, we've got simply all the sides of LTQ and MTQ are congruent. But with that, you can go on to prove some other things. You can go on to prove that this angle is congruent to this angle. And we know KT is going to be congruent to itself. I'm sorry, I hid the T. I'll make that T visible there. Okay, so we know that this is congruent to itself. We know this side is congruent. So we can now prove that KTM and KTL are congruent by side, angle, side. Once we have that, we will now know that we're starting to get pieces of KPS and KRS. So that gives us this. Let me undo that. That was very clumsy. Let's try that again. We know that KPS and KRS are congruent. we can easily state, of course, that, well, let's actually keep building. So now we can say these angles are congruent. We can say that we can now prove that KPT and KRT are congruent. I see how it's like building our way up to KPS and KRS. Okay, we can prove that because, let's see here. We have a total, these two angles will add up to be congruent, which means that angle KTR and KTP will be congruent by subtraction, because they are supplementary to congruent sums. Okay, PTQ and RTQ are congruent sums because these top angles here are going to be congruent. So once we've got that, then we can prove that KPT and KRT are congruent. Okay, and once we have that information, then we have proven pretty much everything we need to prove, actually. We now have proven that KP, we can prove that KP and KR are congruent, and then we can also note that KS is congruent to itself, and therefore these top triangles are congruent, so PS and PR, PS and RS would be congruent. All right, let's look at the last one. So that one takes a few layers, and you can expect problem set D stuff to take some layers. The last one, we're trying to prove that JG and FH are congruent. And to do that, it will probably be best to prove that AGJ and BHF are congruent. And let's see what we have already got. We know AD and EB are congruent. So let's label that. Fump and Fump. Those are congruent. We know BD and EB are congruent. So let's label that. I'll use yellow. Okay, we know that's congruent. And that's congruent. And we know AJ and FB are congruent. All right. Now, with all that information, we also know we can now prove that, well, we can add some information. Let me say that. We can also add that AB is congruent with itself. Let me erase that so you can see that that's a B. Okay, so that will tell us that DAB is congruent to EBA, and that will give us a couple angles that might help us here. So it'll give us that this angle and this angle are congruent. It'll also give us that this angle and this angle are congruent. And that will tell us furthermore by subtraction that this angle is congruent to this angle. And now let's see what else we can work out. Now, of course, the fact that this little angle here, the you can call it DBA and EAB, the fact that those are congruent points to the fact that ACB is isosceles. And the fact that ACB is isosceles will indicate that a couple of the sides here, AC and BC, are also congruent. And I think that's going to start getting us closer to where we need to be. We're trying to prove that JG and FH are congruent. So now maybe we're going to need an auxiliary line. I'm not sure. I'm going to pause and consider that. So I'm definitely thinking auxiliary lines are going to be helpful to us here. I'm going to draw auxiliary lines CJ and CF. And when I do that, let's see, we have a side we have a side here and the included angle, side of the included angle, and that will actually establish that these two sides are congruent, okay, because of side angle side and then kappa kappa. So we can now establish that CF and CJ are congruent. Okay, and we can establish that this angle here is congruent to this angle because of kappa kappa. Okay, so we can prove that that angle and that angle are congruent. Okay. Okay, some other things I've noticed that are congruent that you can play around with here. And part of what I'm getting at is there are going to be multiple paths to victory here. EF is going to be congruent to DJ. And that's getting us a little closer to what we need because, and those are congruent because of side, angle, side, and side, angle, side. So those triangles are congruent, so kappa kappa will lead us to those sides being congruent. Now with that information, now we know these little angles here are congruent here and here. We know this is congruent here and here, and actually now we have what we need to prove that FH and JG are congruent, because we can now prove that these little triangles, not the ones I was originally thinking, but these little triangles here will allow us to prove that these sides here are congruent by kappa kappa. All right, I hope that helped, and I'm going to go ahead and stop the video at this point.